Are you ready to explore the amazing world of operators in Java? If you are a beginner, this is a great place to start. And if you are an experienced Java programmer, you might be surprised by what you learn. So, what are operators in Java? They are a group of characters that allows you to perform mathematical and logical operations on data types like strings, integers, and booleans. That means operators allow you to do everything from simple addition and subtraction to advanced mathematical calculations. But that's just the beginning. There are so many different operators in Java, and each one has its own unique functionality. In this video, we'll take a look at the most popular operators present in Java, and you'll learn everything you need to know about how to use them, what they do, and how they can make your coding life a whole lot easier. But before we begin, if you enjoy watching these videos and find them interesting, please subscribe to our channel because we bring the best videos for you daily. Also, hit the bell icon to get notified whenever we drop a new video. If you are eager to enhance your coding skills across various domains of software engineering, you might want to consider a Caltech Coding Bootcamp. With a state-of-the-art Caltech Coding Bootcamp, you can learn to code and become a full-stack developer within 6 months. Get fully immersed in this accelerated coding bootcamp and become a valued software engineer ready to take on any challenges on the job. The key benefits of this program include Caltech CTME Bootcamp Completion Certificate, Caltech CTME Circle Membership, online convocation by Caltech CTME Program Director, portfolio building on GitHub, up to 17 CEUs from Caltech CTME, and masterclasses from Caltech CTME instructors. There are many more other key features. This bootcamp covers the basic of several different frameworks, including Spring Boot, web services, servlets and JSPs, MVC, JavaScript, MongoDB, and much more. These skills will empower you to kickstart your career as a versatile full-stack developer. So take advantage of this opportunity. The course link is provided in the description box below. Keep watching this fun, interactive and informative video on Java operators, and by the end, you'll be using Java operators like a pro. So let's get started.
Let's get started with today's topic, which is about operators in Java. When we talk about operators in Java, there are multiple types of operators like assignment operators, arithmetic operators, unary operators, then we have conditional operators and logical operators, and we also have bitwise operators. And we will cover all of these operators one by one. We will understand what these operators are and how they work, and we will also look at a demonstration of it. So let's get started. The first operators we are going to discuss is about arithmetic operators and assignment operators, and we will also see if we can cover unary operators. So when we talk about assignment operators, I have again opened the official Java docs here. If we understand assignment operators, we have been using these operators all the while in all of the demos so far. And the basic idea is very simple. Whenever you assign a value to a variable, you use the assignment operator, which is nothing but the equal sign. We have already covered this in multiple demos, so I will not cover this as part of the demo. But what I'm going to cover in detail is about these arithmetic operators. So arithmetic operators are basically used to perform any kind of arithmetic operation on a Java program. It can be an addition operation, it can be a subtraction operation, it can be a multiplication operation, a division operation, or an operation by which you can find the remainder of the division. So we will look at each of these with an example, and as you can see, the symbols are expectedly what you generally use in mathematics. So you see the plus sign here, which is for addition. You see the minus sign, which is for subtraction. You see the star sign, which is for multiplication. You see the slash sign, which is for division. And you see the percentage sign, which is for finding the remainder of a division. So let's see an example of each of these and how we can use them in a Java program. So for the arithmetic operations, I have prepared a demonstration of it in the Eclipse IDE. Again, I'm using the same Java project which I have shown you we created in the previous lectures. So for all the demonstrations, I will just continue in the same project. So again, the way to create a class remains the same. exactly the same as how I covered in the previous lecture in the Hello World program where we created a class. So here also I created a class. I named the class as Arithmetic Demo, and I have a public static void main method inside this particular class, and I have basically tried to demonstrate each of the operation. So let's start with the addition operation first. So I create an integer variable here named as result, and then I try to use the addition operator to make this variable store the result of this addition. So it's a simple 1 plus 2. You can also create two different variables for 1 and 2. Let's say x equal to 1 and y equal to 2. And you can also do int result equal to x plus y. It will have the same effect. But just for simplicity, I have put the literal numbers here. So result is storing the expression value of 1 plus 2. And then I'm printing this value here. You can see I'm printing the result variable here with using system.out.println. Then I'm storing this result into a variable, into a new variable, original result, with using the assignment operator. And then I'm trying to subtract something from it. So now I'm saying result equal to result minus 1. It means whatever the current value of result is, subtract minus 1 from that value. So the value was 3 here, and here 3 minus 1 becomes 2. So the new value of result becomes 2. The original result still holds 3 because it is storing the old value. The new value of result has now become 2. So I'm printing the original result, and then what I'm doing that I'm again assigning the new result, which is 2, to the original result. So now original result and result both are at 2. Then I move ahead and I try to demonstrate the multiplication operation. So I take the same variable result and I say multiply it by 2. So whatever the value of result was, which at this place should be 2, multiply that value by 2. So 2 into 2, the new value of result should become 4 after this multiplication operation. And again, I'm assigning the value of original result to this particular variable. And then I'm showcasing the fourth mathematical arithmetic operation, which is division. So you can see result by 2 here. So basically, whatever the current value of result is, I'm dividing that value by 2. So 4 divided by 2 should become 2. So again, the new value of the result variable should become 2. Then I'm printing the value and again storing the value back into the original result. Then the next operation is again an addition operation where whatever the value of result is at this particular point, which is 2, add 8 to that particular value. So the new result value becomes 10, and then I'm printing that particular value, again assigning the original result to the result. And then to showcase the remainder operation, I'm doing result. We call this particular operator as mod or modulus. So result modulus 7. So the current value here is, in this case, would be 10. So I'm saying 10 mod 7. So 10 mod 7 would become 3, because if we divide 10 by 7, the remainder should be 3. And this modulus operator is used to calculate the remainder of a division operation. So that 3 will be stored in this result variable, and then we print that particular variable. So that is what I'm doing. If I take you back up there, I'll just minimize this window and this window as well. So if I take you back to the starting, I'm doing an addition first here at line 7. Then I'm doing a subtraction at line 12. Then I'm doing a multiplication at line 17 and a division at line 22, and then again an addition at line 27, and then a modulus at line 32, and I'm printing the respective values. So let us run this program and see what results do we get. So I right click, I go to run as, I go to Java application. There is also a shortcut for it. If you want to use the shortcut, you can use that. So I click on this and the output is displayed here. So you can see, let me bring this output back to its original position. Yeah, I just dragged it here to the top, to the bottom. So if we start from the top and see what all results did we get printed. So line 9 says 1 plus 2 equal to the value of result. So 1 plus 2 equal to, at this particular point, the result value was 3 because 1 plus 2 equal to 3. Moving on, the next variable here is minus. So the current value was 3. We said 3 minus 1, which becomes 2. And we store the value of result or 3 into this result variable, and we print that value at line 14. So original result plus original result is 3, then a string here -1 equal to, so this is just a string, and then the actual current result value, which is 2. So far so good. We move ahead, and then at line 19 we are multiplying the current value of result by 2 and again displaying the original result and the current value. So 2 is the original result here, because here 3 minus 1 had become 2. So original result value was 2. Multiply that by 2 becomes 4. Then moving on to the line 24, 4 by 2 should become 2. So 4 by 2 equals 2, the current value of result. Then again moving on to the next variable at line 29, now the result value should become 10 because 2 plus 8 is 10. And again we are printing the original result and then the current result value. So the original result was 2, then we added 8 to it, and the new result value had become 10, which is coming from this particular variable. Moving on to line 34, we are again printing the original result, which was 10 here, and then we are saying this particular string, which is modulus 7, and the current value of result is coming from this expression, which is 10 modulus 7. And like I said, modulus or mod operation is basically used to calculate the remainder of a division operation, which, so 10 divided by 7, remainder is 3. So that becomes 3, and that's why you see the value 3. So this is a demonstration to show you how we can use the addition, multiplication, subtraction, division and modulus operators, which are all the arithmetic operators. Unary operators. So when we talk about unary operators, technically they are also arithmetic operators, but they provide us a shorthand, or they have a more advanced meaning. So if you see on the screen, these are the unary operators. We call them as unary plus, unary minus, increment operator, decrement operator, and logical complement operator. So when we talk about the unary plus operator, basically it is used to indicate a positive value. So whatever value you are having, it will just make that number as positive number. You might be wondering that this plus has an addition meaning as well, right? Which we saw in the previous example. Yes, that's correct. But when we use that addition symbol, we use that between two variables. But when we talk about unary operators, they are used with a single variable. That is why the name unary, because they are used with a single variable. They require only one operand. So unary plus basically makes any number positive. Unary minus negates an expression and makes that number negative. Increment operator increments the value by +1. Decrement operator decreases the value by -1. And logical complement operator inverts the value of the expression from true to false or false to true. Let's understand this with the help of an example. So I have created a class here called unary demo, and I have a static void main method here, and I have created a variable called result, and the first example is about using unary plus. So I'm creating a variable called as result, assigning the value as 1 and just putting 1 plus in front of it, which makes this as positive value. Though we can argue that this also has the same effect as this, and yes, that is true. But in case if this value was written as something like -1 instead of plus, then we could basically make that number positive by just putting plus in front of it. So that's basically the power of unary operators, and that's how you generally use unary operators. So I'll just put it back to +1. The next example is about decrement operators. So the current value of result was 1 because we did this. Now we are saying result minus minus, which means whatever the value of result is, just decrement it by 1. So the current value was 1. So now the new value of result after this evaluation becomes 0. So at line 14, we print the current value of result, which is 0. Moving on at line 16, we are using the increment plus operator here, which means whatever the current value of result is, just increment it by 1. So the current value of result was 0 till this line. So it becomes 1 because this means increment by 1. So line 18 will basically print that value 1. And then at line 20, I'm using the unary minus operator, which means whatever the value of result is, just negate it. Just put a negative in front of it. Just make that number negative. So if I just say minus result, the current value of result was 1. So it became -1. And then to showcase the negation operation, I created a Boolean variable, named it as success, assigned the value of this variable as false, and printed the value of success variable as is first, and then printed the value of success with a negation in front of it, with an exclamation mark, which will basically flip the value or invert the value of a Boolean variable. So if this was false, line 28 should print true. If this was true, line 28 should print false. In this case, this is false, so the line 28 should print true. So let's right click on this and run this program and see if we get the expected output. And yes, we see the output here. So let's try to interpret the output now. The line 10 should print 1. Yes. Then line 14 should print 0. We see 0 here. Line 18 should print 1 because we use the increment plus plus. So 0 plus 1 became 1. Then we use the unary minus operator. So the value should become -1. Yes, we see -1 here. And then for Boolean variable, we should see first the false because the value is printed as is. And then we are printing a negated value. So we should flip the value from false to true. And yes, it is printing the value as true. So this was about unary operators. Now, when we talk about these increment and decrement operators, what if I put this particular value in front of result? What effect is that going to happen? Let's analyze that part as well. So for that, I have prepared a separate demo. Again, I've created a class called pre-post demo, and it has a public static void main method. I'm declaring an integer variable I with the value as 3. So the I becomes 3 here. And then I'm saying I++. As we have already seen in the unary demo example, this should increment the value of 3 to 4. So it will print 4, expected, right? Then at line number 9, I'm putting this plus plus in front of I. Now what will happen? Now it is going to increment the value of I and then basically assigning the value of I. So the whole difference between I++ and ++I is that in this case, the value of I is assigned first and increment later. In this case, the value of I is incremented first and assigned later. So here the value from 4 becomes 5. So at line 11, if you see, if we print I, it will print 5 because we are saying that first increment the value and then update the value of I. So increment happens on I equal to 4 and I becomes 5. At line number 13, it becomes more interesting because here inside the system.out.println statement itself, I'm saying plus I. Now what will happen? Like I explained, first the value will be incremented and then the value will be assigned. So before printing, the value is getting incremented. So the value from 5 becomes 6 here at line 13. But if I try to do this, now I'm saying first assign the value of I and then increment it. So I at this line is still 6 because I has already been assigned 6. And as the post increment says, if you put this plus plus after the variable, it means that you are first assigning the value and then incrementing the value. So anything which happens after line 15, the value of I will become 7. But at line 15, the value of I is still 6 because we are using a post increment operator. So the value is still assigned to I as is and then incremented. And when we do system.out.println, the assigned value is printed, not the incremented value. So like I said, after line 15, the value of I will become incremented by 1 and it will become 7. So hope you understood this example and the difference between the pre-increment and post-increment. Remember the thumb rule that if we put plus plus before a variable, like at line number 9, the value will be incremented first and then assigned. So at line 13, the updated value will be printed because the first we are doing the increment and then we are printing the value or assigning the value. Similarly, at line 15, we are first printing the value and then incrementing the value. So when the value is printed at line 15, the old value of I will be printed, but after line 15, the new value of I will be accessible to the program. So let's right click on this and run this program. And now if we see the values, we assigned I to 3. We did a post increment here. So I becomes 4. We print the value of I. So here the value of I is 4. We see 4 here. Then at line 9, we are saying plus I. So 4 plus 1 becomes 5. Though this is a pre-increment, but since we are not printing this plus I as is, it does not have any change. So the value of 4 becomes 5. At line 11, we print 5. Then at line 13, we are saying plus I, which means increment the value of I first and then assign it. So the value of 5 becomes 6 and then I gets updated and printed. Similarly at line 15, first the value of I is assigned and printed and then incremented. So at line 15 the value is still 6. You see this 6 here, and then the value is incremented. So after line 15 the value becomes 7. So that's how we are basically using the unary operators, equality and relational operators. When we talk about relational operators, they are sometimes also called comparison operators. And the basic idea behind using these operators is to compare things or compare the values of variables or compare the objects in Java. So in Java, if you need to compare anything, for example, if you want to compare if something is less than the other thing, or something is greater than the other thing, or something is equal to the other thing, then you need to use the comparison operators which are provided by Java. Here you can see I have opened the official Java docs, and you can see a bunch of comparison or relational operators. Both of the terms are used interchangeably. Some people call them comparison operators and some people call them relational operators. So you can see if I want to compare if an object or a value is equal to another value, then I use the double equal sign. If I want to compare for non-equality, I will use exclamation with an equal to, which means not equal to. If I want to do a greater than comparison, then I will use the mathematics greater than symbol. If I want to do the greater than equal to or less than equal to, they again follow the same kind of terminology as we see in mathematics. So this is all we have in terms of the relational operators. So let's understand the usage of these operators with the help of some examples. So as you can see, I have created a class here, which is called comparison operator. There is a public static void main method inside this class. And this method has two variables of integer type called value1 and value2. Value1 has the value 1 and value2 has the value 2. And then I am trying to compare the value1 and value2 variables using the different relational operators we just covered. For doing that, I need to use a conditional operator as well. We will be covering conditional operators in much detail in the upcoming lectures. But for now, you can understand that when we talk about conditional operators, we talk about if and else statement. So if is again a keyword in Java, which can be used to compare things. And the syntax is very straightforward. You write the if keyword and then you write the actual comparison syntax or the actual comparison expression. So in the first example, we can see that I'm writing a condition which says evaluate if value 1 is equal to value 2. I should put a curly braces around here. You can see there are no curly braces here, but that is for a case when you have only one statement under it. But again, I will cover this in detail and I don't want to confuse the audience here. So I will just put curly braces around all of these if statements so that it becomes easy to interpret what is actually going on in these code blocks. As we know that these curly braces are used to define a code block. So the first if block says compare if the value 1 is equal to the value 2. If yes, then this condition will become true and the control of the program will go at line number 10. If this condition is not true, then the control will not go inside 10 because this condition is false. So it will never go to line 10 and it will move to line 11 or 12 instead. Similarly, the next condition is we are comparing the value 1 is not equal to value 2. So this condition will only be true if these two values are not equal or unequal. And if that is the case, then line 14 will execute it. Otherwise, line 14 will not be executed. Similarly, in this condition, I'm saying compare if value 1 is greater than value 2 or not. So if the actual value holded by value 1 variable is greater than the value 2 variable, then this condition will become true and the line 18 will be executed. Otherwise, it will be skipped. Then similarly at line 20, I'm doing the reverse. I'm comparing if value 1 is less than value 2. If that is the case, then line 22 will be executed. Otherwise, it will be skipped. And at last, I'm also showcasing an example of less than equal to operator, that you put less than and equal to together, and again you compare the two variables. Similarly, you can also use greater than equal to variable comparison operator as well in this example. So we have an example of equality, not equal to, greater than, less than, and less than equal to. Let's run this example to understand. So for running the example, I will just right click here, go to run as, and click on Java application. And we can see the output here. So as the value 1 holds the value 1 and value 2 variable holds the value 2, obviously 1 is not equal to 2. So the first condition is not going to be evaluated to true. So line 10 will never be executed because 1 is not equal to 2. Similarly, if I talk about the next condition, which was if value 1 is not equal to value 2, then execute statement 14. And yes, 1 is not equal to 2. That's why we see this particular system.out.println here. We see this printed. Moving on, is value 1 greater than value 2? So is 1 greater than 2? No, it's not. So line 18 will never be executed. Then the next one is value 1 less than value 2? So yes, 1 is less than 2. So line 22 will be executed. And we see the line 22 output here, system.out.println output. Moving on, is 1 less than equal to 2? Yes, 1 is less than equal to 2. So this particular condition is also true. And line 26 will be executed. And that's why we see this here. And that's all. So we can see that we are able to use these comparison or relational operators to evaluate different conditions. And we write those conditions using the if block. And again, if you do not understand the if block fully, don't worry. We will be covering the if blocks in detail. But the focus here is in using the operators, the not equal to operators, the greater than equal to operators, less than equal to operators, etc. So I hope these operators give you better understanding of how to use them. Now moving on to the next section of this comparison operators, sometimes we also use some logical terms to do the comparison. For example, if I just move down here and I show you these conditions here, we call them conditional operators. Conditional operators are used to evaluate the conditions like and or, and we use them in two ways. Either we can use it as ampersand or double ampersand, or we can use them as pipe or double pipes. So the idea is basically to evaluate if one condition is true and other condition is also true, or one condition is true or other condition is true. So whenever you want to combine two conditions together, that's where you're going to use these logical operators or conditional operators. You can also use the simple English keywords like and or you can use the logical representation of these keywords. For example, ampersand, ampersand, or double ampersand is equivalent to and. Similarly, double pipe is equivalent to or. So we can use these as well interchangeably. You can use either of these operator representations to run a conditional check in composition, meaning you can compare two conditions saying, okay, if one is true and second is true, or one is true or second is true. So the whole focus is here in and or comparisons. So let's switch back to the IDE and let's look at an example of this to understand this in detail. So I will again take the similar kind of example. Again, I have created two variables here, value 1 and value 2. Value 1 has value as 1 and second variable value 2 has value as 2. And then I'm writing two conditions this time in the same if block. You can see I am writing first condition saying is value 1 equal to 1 and is value 2 also equal to 2. So this whole if condition is only going to be true only if both of the conditions are true. That's the property of and will force that both the conditions on the left hand side of it and the right hand side of it hold true, and then only the whole expression is going to hold true. Even if one of the conditions evaluate to false, the whole if expression will evaluate to false. Similarly, for or conditions, we again write a left hand condition and a right hand condition, and in between we write this double pipe. We can also write or in English. That will also have the same effect, and this will evaluate in a way that this whole expression will evaluate to true if even a single condition either on left side or right side of it becomes true. So OR will just need one expression to be true to make the whole if condition true, whereas AND will force both of the conditions to be true to make the whole expression as true. So AND will require two trues to actually become true, but OR condition will require only one true to become true. So if we try to understand this logic, here I'm saying that if value 1 is equal to 1, which is correct, and value 2 is equal to 2, then make this condition as true. So yes, in this case, this condition will evaluate to true because value 1 has value 1 and value 2 has value as 2. So it will print the line 10. Whereas in the next condition, I'm saying evaluate if value 1 is equal to 1 or value 2 is equal to 1. So either of the expression if becomes true, either the left side, this expression, or the right side, this expression. Either of the expression becomes true, this whole condition will become true and line 14 will be executed. Line 14 will not be executed only in a case when both of the conditions here become false. For example, if I write it like this, then we know that value 1 is not equal to 4 because it's 1 and value 2 is not equal to 5 because it's true. In that case, both of the expression will become false and then line 14 will not be executed. If I write it like this, then the left hand expression is evaluated to true because value 1 is 1, but the right hand expression is false. But it's fine. The line 14 will still be executed because either of these side is true, so the whole expression becomes true. Similarly here, AND will require both of the expressions to be true, and if either of them becomes false, then the whole expression becomes false. So in the current state, line 10 will be executed, but if I change this to this, then the left hand side of this ampersand will evaluate to false and the whole expression will evaluate to false in that case, and line 10 will never be executed. Let's try to run all of these scenarios to make a better understanding of this. So in this case, both of the conditions should work fine. So I will just right click and run as Java application. And yes, we see this line 10 being printed and we also see this line 13 being printed. So both of the lines are printed correctly. Both of the conditions are evaluating to true. Now let's try to play around with it. Let me change this value to 4. So now value 1, this left hand side expression is false, which should make the whole expression as false, and it should not print the line 10, which is this statement. So let's run this program and see if that works. Yes, we see that this particular line is not printed now because this whole expression became false because the left hand side of this expression became false. Similarly, in the OR case, either of them have to be true. You can see currently value 2 equal to 5 condition will actually result in a false condition because this is not a true. Value 2 is actually 2, not 5. And still we see this particular expression because either of them have to be true. If I make both of them as not true, now both of the conditions on the left hand side of pipe and right hand side of pipe are false conditions. What will happen now? Nothing will be printed. The reason for that is that value 1 is also that this condition is also false and value 2 condition is also false. So the whole expression became false and this was already false. Bitwise operators. Now bitwise operators are very less commonly used in the Java programming world. Generally we don't use them and generally we don't need to use them. You would generally use them when you are doing really complex bitwise calculation where you need to manipulate the bits. Now what are actually bits? So if you remember when we talked about the integer type variables, we talked about how much memory each of the variable type or data type was going to consume. We said that this will take 1 byte and this will take 2 bytes, etc. 1 byte is basically made up of 8 bits, and bits are nothing but positions where either a 0 is stored or 1 is stored. Actually, the whole machine will convert your whole program ultimately in zeros and ones, which are nothing but bits. So if you want to do the manipulation at that level, so now you can understand you are actually working right at the machine level understanding. So if you want to manipulate the bits which are going to be understood by the machine at that level, then you can use bitwise operators. But like I said, generally we don't need to use them. Now, when we talk about bitwise operators, there are multiple ways in which we can use them. We can use them with the standard AND or OR operations. If you remember, we covered this AND or OR operations in the previous lecture. You see a difference here. that in case of AND, we are using a single ampersand and not double ampersand. This is one of the concepts which we did not cover in the previous lecture, and I would just like to brief you about this concept, that if you use double ampersand, that is also called a short circuit operator. And if you use a single ampersand, that is called a standard operator. To build an understanding about this, I will just quickly recap of what we covered in the last lecture, and we'll try to explain these concepts as well. So let's go to the logical operator demo. And here, if you remember, there were two ampersands and two pipes. This is also a valid expression. A single ampersand is also a valid expression. The only change is, in this case, even if the left hand condition evaluates to false, still the right hand condition will be evaluated. Although we know that in case of AND, either of the expression needs to be false and the whole expression becomes false. So Java provides an advantage with that if you use double ampersand, and if the left hand operation becomes false, then it will not cover the right hand operation. It will not even evaluate the right hand operation because it doesn't matter. If the left hand operation has already returned to false or evaluated to false, then no matter whether right side is true or false, the whole expression is still going to be false, right? That's the property of AND. One of the side has to be false and the whole expression becomes false. So why evaluate two sides? Why waste the memory in evaluating the right side when the left side has already turned as false? Java takes advantage of that, and that's why if you use double ampersand, you save a bit of processing power of your computer by just evaluating the left hand condition. And if the left hand condition is false, it will skip evaluating the right hand condition and just make the whole expression false. But if you use this, a single ampersand, then both sides of the expression will be evaluated irrespective of their output. So in this case, even if the left hand expression is false, it is still going to evaluate the right side expression. And similarly, it works for the OR case as well. In this case, in OR case, as we know, if one of the condition is true, the whole condition becomes true. The whole expression becomes true. So if the left hand side becomes true, and if you use a single pipe, then it will still evaluate the right hand side. But if you use double pipe like this, then if the left hand side becomes true, then it knows that it does not matter if the right hand side becomes true or false, because ultimately the whole expression is going to be true if either of the side is true. So if the left hand side is already true, it will not evaluate the right hand side and it will say the whole expression is true. That's why you see the single ampersand being used for bitwise, just to explain why it is used and how it is used. For OR operations in bitwise, you use this cap or whatever you want to call it as. And for the inclusive bitwise or operation, you're going to use a single pipe. You also use some shift operations where you shift the value of bit of a particular variable to either left or right. Again, these are very complex calculations. If you want to use that, please read about this and use that. But in today's demo, what we are going to cover is the AND and OR examples of bitwise operations. So here I have again created a class called bitwise operator. I have a public static void main method. I have two variables here, which are int a equal to 5 and int b equal to 7. Now these 5 and 7 are actually stored as bits, as zeros and ones in the computer's memory. So how they are actually stored? They are stored in a standard bit representation, which you may have studied in your mathematics. If to give you a recap, this 5 will basically be written in the memory as this 0 1 0 1, and it starts from here. 2 raised to power 0 into 1 becomes 1, 2 raised to power 1 into 0 becomes 0, 2 raised to power 2 into 1 becomes 4, and 2 raised to power 3 into 0 becomes 0. So 0 plus 4 plus 0 plus 1 becomes 5, and that's how 5 is displayed to you. Similarly for 7, 2 raised to power 0 into 1 is 1, plus 2 raised to power 1 into 1 is 2, so 1 plus 2, 3, plus 2 raised to power 2 into 1, which is 4, so 1 plus 2 plus 4, 7, and 2 raised to power 3 into 0 is 0. So 0 plus 4 plus 2 plus 1, which is 7, and that's how this 7 is built and stored. And now if you try to do this, if you try to write this condition, you can also write the condition into a system.out.println block, and it will basically evaluate this condition. So now if you say A and B, in this case, this is going to do a bitwise operation because this is bitwise operand. It is going to do a bitwise operation, and what would be the result if you do an AND on this? So again, use the same logic as if in case of AND, if 1 is false, then the whole expression is false. So 0 and 0 becomes 0, 1 and 1 becomes 1, 0 and 1 becomes 0, because 0 means false and 1 means true. So if either of them is false, the whole evaluation becomes false. So that's why 0 and 1 becomes 0, and 1 and 1 is always 1. The value of this is again 5, as we already have evaluated. Similarly, if we do a bitwise OR, and if we do this, again we are doing an OR operation. So 0 or 0, or basically false or false, becomes false. True or true becomes true. False or true should be true because one of them needs to be true. So this is false, but this is true. So the whole value becomes true. And finally, true or true is also true. So this is the final bitwise OR result. And if we convert this into an integer representation, that becomes 7, because 2 raised to power 0 into 1 is 1. 2 raised to power 1 into 1 is 2. So 2 plus 1, 3, plus 2 raised to power 2 into 1, which is 4. So 4 plus 2 plus 1, which is 7. And plus 2 raised to power 3 into 0, which is 0. So 0 plus 4 plus 2 plus 1 becomes 7. And that's how you get actually 7. So let's see if we get 5 or 7 in this bitwise operation. Yes, we can see the values as 5 and 7. So this is a bitwise operation happening. Similarly, you can also use the shift operations, where in case if you're using this particular kind of representation, or this particular kind of representation, they are called left shift and right shift operations. So if you use this in front of a variable, then for example, this 1 will be shifted here, and this 0 will be shifted here, and this 1 will be shifted here. So that's how the whole value is going to shift. Whole bits are going to shift one by one towards left. Similarly, if you're using the right shift, then all the bits are going to be shifted towards right by 1 bit. That's the whole concept of left shift and right shift bitwise operations. And if you want to know more about this, please read some official examples from the Java doc and some other examples available on the internet to build an understanding on this.
And with that, we have come to the end of this tutorial on operators in Java. I hope you guys must have got a good idea about what operators are and how to use them in Java. If you feel that we have missed out on some important topic that we were supposed to cover in this video, then please feel free to drop them down in the comment section below, and a team of experts will definitely answer them for you. So thank you so much for being here guys today. We'll see you next time. Until then, keep learning and stay tuned.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.